Again for coming. So I'm Forrest. I'm the machine learning engineer at Vectara. So let's begin talking about what a RAG is. Since some of you, many of you are already expert in this domain, but many of you are not. So what a RAG is? RAG is a way to build a knowledge engine that can communicate with us without fine tuning on a large amount of data. So for example, let's say we have a knowledge base of all the books in the library. Okay, and all of a sudden I want to ask a question. What is Splenda? So RAG has two steps. The R in RAG stands for retrieval, while A stands for augmented, G stands for generation. So there's two steps. First is the retrieval step. In the retrieval step, first, all the documents that matches your query, those who match the most with your query, will be retrieved. Okay, and then from those retrieved documents, we will fed them to, for example, a large language model, and the answer will be extracted from those documents. You can imagine as putting up a large amount of prompt into, for example, ChatGPT, and ChatGPT from there, they can answer your question. But the thing is, we do not have to feed all the documents to ChatGPT, because that's going to be too much. And we only need those most relevant ones, put them into a language model, and ask a question, and get the answer. That's the idea of RAG. So you can imagine, by changing the document, you can quickly repurpose your knowledge pipeline for different kinds of knowledge. So if I upload a bunch of documents, about computer coding, then this pipeline can answer computer coding questions. If I replace them by a bunch of recipes, they can all of a sudden answer cooking questions without any fine tuning. All this could happen instantly. This is a RAG. All right, so I'm going to show you how it is to build a quickly reconfigurable knowledge base which you can interact with in Vectara's platform. I'm going to show you in several approaches. Vectara is a developer-oriented company, so our first-class solution is based on is through computer programming. So I'm going to give you some quick demo on how we can do that. The first is I'm going to show you using an unofficial SDK, which I wrote for Vectara myself. So it's unofficial, but it's really easy to use. So let me show you, the notebook. So this is my Jupyter notebook. So first of all, my SDK, my unofficial SDK, is already published on PyPy. So you can use the pip command to install it. So if you go back here, you can just pip install it, then you can have it. And then next is you import the Vectara Python SDK, of course. You import it, and then in order to do this demo, I'm going to use some documents. Okay, so here I just crawl 3 documents from the internet. Now the 3 documents are, the first one is Vectara Employee Handbook. Okay, the other are 2 open source projects I'm working on. Okay, they're about how to do layout in build software interfaces. So you can imagine one is about our internal policy, the other is about computer programming, a bunch of API stuff. Okay, so once you have, Vectara supports a greater variety of document formats. So you can see these documents I crawled, some of them are, let me zoom it a little bit. Hold on a second. Let me hide it. Okay, so you can see, some of the documents are in the PDF format. This our employee handbook is PDF, while the menus of the software, they are directly crawled from GitHub. So they are markdown files, and we can support all these kind of file formats. So now I have the files, let me turn them into a knowledge base. So the first thing you need to do is you need to initialize a Vectara client. What you do is you can go to your Vectara console, which is, I've got to hit them by this one, it looks like, but let me do it here. So you can go to our console, and in our console you can obtain all kinds of credentials, like for example your customer ID, and you go to authentication, you can get your secrets, your password, all those kind of things like secrets, user ID, all those information. So you plug in this information. I save them in a text file called keys.py. So you can just save, so to make it easy, I just save them in the file. So what you need to do is you can first initiate a Vectara instance, okay, and you plug in these 3 credentials, and then you're ready to go. So the first step of RAG is you need to create something called a corpus. A corpus means a collection of documents. So you say, okay, here I can say use this function, create a corpus, I create a corpus, and this will return me a corpus ID, which I will use later. So imagine basically you have a bunch of files, you give them a name, numerical ID. So I have that. Then I could upload files to my document, to my corpus. So I saved, you can see my download command here. I downloaded all these files under the test doc folder. So, and this SDK allows you to batch upload all the files under one folder. So we do this upload, which means that we're going to upload all documents under this folder test doc. So all of them got uploaded. And if you go to our console by that time, you would be able to see all your corpus here, for example. These are all the corpora. And the one I created today is of document ID 19, we call PyDay corpus. So you can come here, see, these are the 3 files I uploaded, the 2 markdown files and 1 PDF file. And with all these files, you can start making queries. So my SDK has a function called query. So you just say what query you want to ask and to which group of documents. Okay, so for example, my corpus ID was 19, so I asked for the corpus ID a question. Say, how can I rearrange objects? So before we see the answer, let's make a guess. I have 3 documents. 2 about API user manual, 2 are API user manuals. 1 is Vectara employment handbook. Which one of the 3 documents? Which ones of the 3 documents are going to give me the answer to this question, how can I rearrange objects? Remember those 2 software APIs, they're about making GUIs, like software interfaces. So let's make it easier. Do you think answers for this question, how can I rearrange objects, are going to be likely from Vectara user manual, employee handbook? No, very unlikely, right? Because as employee, you were unlikely to rearrange. Probably you could say, can we rearrange chairs in the conference room, right? But that's usually not an employee handbook. Yes. So if we ask this question, so this is what Vectara's answer will look like, and I reformatted it. So first of all, Vectara will give you an answer, okay? So let's read it, okay? So it says, to rearrange objects, you can utilize the direction attribute in a phonics decorator. Okay, manually resizing position objects can be tedious and inefficient process, blah, blah, blah. So it tells you how to do that. And Vectara not only gives you an answer, all our answers are grounded. You can see this citation numbers here after all the sentences, and they all map to different references, okay? And in Vectara's raw return, we have this matchness, basically how much this piece of text in your knowledge base matches your query, okay? So here I'm just showing top 5 queries. You can see they are all indeed from this software manuals, okay, are all markdown files. And they are indeed, if you read them, they are all about how to arrange objects in a GUI, in a software graphic interface, okay, including, for example, auto layout, right? You can even see some HTML code being part of it. So let's ask another query. Can I bring friends to the office? Now let's think about it. Would this question be more likely to be answered from using information from Vectara Employee Handbook or the other software manuals? Probably the first case, right? The Employee Handbook, right? Because about bringing friends to the office, indeed. So in this case, I'm going to display you a raw, a processed result in JSON format, because this is in this example, this demo, by default I will print markdown files, okay? But sometimes you probably want a JSON string to make it easier to use, okay? So here is the JSON string. So again, this is the answer that the Vectara platform generates. And all these answers, remember when we do, for example, we do not use your data to do the training. Okay, so your data, we do not memorize your data in our model, okay? So this answer is purely generated from the information provided in the document. And then once again, all the answers are cited, okay? So for example, the first one says, monthly furry friend Fridays, where you can introduce your pets via video conference. Right? That's from our employee handbook about animals. Of course, this is something quite interesting, right? Plus, they add a colorful, I don't know, this is a, UTF-8 string, I don't know what it translates into, to the team meeting. Yeah. Because they all have things about animals, about friends. Of course, this first one is really interesting friend, furry friend. It's basically animals, pets, okay? Here we go, like parrot or rescue rabbit. So this is how easy it is to use Vectara to build a RAG system. So if we put them all together, I can show you probably a shorter code snippet. That's how it is to do. First, import our library, and then just several steps. First, authenticate with our platform. Create a corpus, upload files to the corpus, then you can ask your questions. It's just that straightforward and easy. I'll stop here. Any questions?
Yes. Can you change the code to show me from which section of the employee manual you pull that snippet out, and also what page number or what's?
Yeah. So in my simple demo, I did not return the page number, but I do.
Or the section heading, something like that.
I don't have a section heading. So in RAG, what happened is all the text in your document got chopped into many chunks. So for example, here it says this is the source. This is one of the chunks being extracted from your document. And this becomes actually the foundation to generate the answer, the first sentence. Like you can bring your friends to the...
If I have to reference the document, if the document is 200 pages long, where do I go?
Okay, that's a good question.
We want to take questions at the end or now?
Okay, that's fine.
I don't know. Do you?
Okay. So one way to the question was, how do we get reference a 200 document, a page document, right? So when you get the return from the API, the return of the actual response, you get the text that was matched. You also get kind of the position in the document and the place in the character set, and you can actually match that to the document. If you want to show it in the document itself, let's say it's a web page, there's kind of general techniques that are not part of Vectara, but I can show them later on if I can share this afterwards. For example, I don't know if most of you know, but browsers have this thing where you can actually give it a snippet of text in the URL and a special formula, I forget what it's called exactly, and it will go to that URL and actually find that matching text and browse directly to where you are. And PDF has a similar technique. So if you click on this and find, you can automatically show that. But generally, the way to do it is you get kind of a location in a document, and you can use that to show. All right?
Yeah, thank you, for of course.
Including Excel also, what are the tab numbers or Excel sheets?
Including Excel.
You want to use the mic?
Yeah, okay. So Excel sheets, I don't think
it's
so.
on.
Oh.
It is on.
It's on. It's on. Okay.
I've not tried with Excel sheets, but I can try and let you know. I think I've not seen a way to do that that's easy in terms of like the HTML web pages. But the other thing to remember about Excel sheets is, what do you want to index from them? Usually they're kind of behaving like a table, right? It's like a table in a database. You have columns, and the columns have text. And how do you ingest that is another story. I don't want to interrupt this flow here, but maybe catch me afterwards, and I'll talk about Excel sheets.
Okay.
Thank you.
Thank you. Well, thanks for the question. Those are all interesting questions. All right. So for the sake of time, I'm not gonna demo since this slide is going to be shared with the public, I also have a different another Jupyter notebook which shows you how do you make raw HTTP requests with our endpoint to do all these steps, creating corpus, authenticating with our server, uploading documents, and making a query and get the answer back. So it's all there. All right, and so many of you probably don't know, say, I don't know how to coding, how do I try out your Vectara platform? That's easy. So there are several ways to do it. So first way is that actually this SDK, it comes in with a built-in web interface. So for example, you can drag and drop a PDF file, add it into your corpus. You can feel free to play with it. Another thing is that Vectara, we have this console. So you can play with this console. For example, you can from here, of course, I don't think you can add files, but you can make queries. Okay. So for example, can I bring animals to the office? Okay, yeah, so see, this is the answer, they have citations, and this is the sentence from the document, okay, from the user manual. Yeah, okay, all right, so this is another way for non-tech savvies to try out our platform. All right, so let's continue. All right, so next I want to talk a little bit about hallucinations, and that is an important issue in RAG, and that's a strength where Vectara is doing good as a leader in the industry. So you probably know that people using large language models, and sometimes they make up things. There's a very famous, interesting case. A lazy lawyer tried to write the petition or complaint using ChatGPT, but ChatGPT made up cases. It has lots of cases that does not exist. So that's the issue of hallucination. Now, hallucination in RAG is a little bit different from the example I just talked about. So let's look at an example actually, on real data. Actually, this is a real benchmark data set for RAG. So one of the queries is what is a Splenda, okay? And then this is the source document being provided. So this RAG system is supposed to only answer questions based on information mentioned here. Okay, but in one of the LLMs, when I test it, it gives me this answer. It says Splenda is a brand name for oh geez, I don't know how to pronounce this. Saccharose, a non-nutritive sweetener, right? So, but if you look at this document, of course we don't have time, but you look at it does not mention the chemical name of this Splenda. Okay, so in this case it is factual, but it is not supported by the source. So in this case, we also consider it as hallucination. Okay. All right. So, hallucination is a problem in RAG because it will involve large language models in the generation stage. So Vectara has released a model called Hughes hallucination evaluation model to tell you how likely our generated answer is, whether it's really supported by the document you provided or it's some memory of the language model in another word, in another life. The reason we call it Hughes because it's one of our colleagues, Simon Hughes, who laid the foundation of this model, but he unfortunately passed away. So in memory of him, we named this model after him. So this model was released last November, and it's totally open source. You could access it from Hugging Face Space. If you click this link, you can do that. You can access it. And now let me show you how to use this model, and I will give you some examples. It really works. So it will be okay. So that's another notebook. All right. So remember, hallucination means that a sentence generated by a language model is not supported by the document fed into it as the input. Okay? And again, this input is not the fine-tuned input. It's input you just put into the prompt. So therefore, let's talk about some cases. Let's talk about some sentence pairs. Okay. So for example, let's talk about this example. The source says goldfish are being caught weighing up to 2 kilograms and koi carp up to 8 kilograms and 1 meter in length. Okay? Yeah, but then the summary says this. Says koi carp can be as heavy as 2 kilograms and as long as 1 meter. Do you think this summary is supported by the article? Is loyal to the article or consistent with the article? No, it's not, because it made a mistake on the weight of the fish. Okay, the koi fish is 8 kilograms. The 2 kilogram is about a different fish, about good fish. Okay, so we have several examples. Let's look at another example. It says the first vaccine for Ebola was approved by FDA in 2019 in the U.S. 5 years. Oh, it didn't. Hold on, let me do it slowly. Okay, all right. Yeah, the Ebola vaccine was approved by FDA in 2019. In the US, 5 years after the initial outbreak in 2014. To produce the vaccine, scientists has to do blah, 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 blah. Scientists say a vaccine for COVID-19 is unlikely to be ready this year. Okay, so therefore, if the summary says you won't get a COVID-19 vaccine this year, is this summary consistent with the input document? It is, right? Because scientists, the document says, scientists say that the vaccine is unlikely to be ready. Oops, sorry, I should have brought a mouse rather than using my touchpad. Okay, now this is what the source says, right? And the summary is consistent with this statement in the news article. All right, so let's put into place. So we're going to check whether these examples, whether they're consistent or not. All right, so in order to use the HHEM, you'd have to pair them into a format where the document, the input source, the source, and the statement generated by language model, to concatenate them together with a special token called SEP, which is a separator, to separate these two parts. You put them all together, for example, like this. So this is the first sentence pair, right? So I have two parts. The first part is the potential support, okay, and then the second part is the sentence generated by large language model, whose consistency with the source I'm going to check against. And I separate them with the special SEP token. All right, and then I'm not going to run this model on my local computer. I'm going to take advantage of Hugging Face API inference endpoint. So I'm going to say, hey, I'm going to make a inference, okay, and my model is Vectara's hallucination evaluation model. And then I send my payload to this endpoint, and endpoint will report me a bunch of scores. So these scores indicates how consistent in a text pair, the second text is consistent with the first text. And the lower the score is, it's most likely it's not consistent. So actually this is a score, we shouldn't call it a hallucination score, we should call it a consistency score. So the higher it is, it means it's consistent, it's being supported. So, look at this one. This one has a consistent score of 0.96. It's very close to 1. This is the third example I just showed you. That scientists said that this vaccine, COVID-19 vaccine, won't be available this year. And all other examples, they are inconsistent examples. They distort the facts. Okay? So maybe we can examine one more before I run out of my time. So, for example, here it says Mr. Keller said government believes Mr. Gordon would quit after he was recently accused of domestic violence. Let's look at the second sentence in the pair says. The second sentence in the pair says, Mr. Keller said he would quit after he was accused of domestic violence. So this may give you a feeling. Who was accused of domestic violence? It's Mr. Cater, right? But the original sentence says that it's Mr. Gordon would quit because he was recently accused of domestic violence. And our model precisely caught this subtle difference and give a consistency score of 0.21. So when you use our model, if you get a number below below like 0.5, that's most likely these two sentences, this pair of two texts, they are inconsistent with each other. If it's above 0.5, most likely they are consistent with each other. And the higher they are, the more consistent they are with each other. And even the first example, remember the fish example, where the second sentence mixed the weight of goldfish with carp, okay? And indeed, our model was able to catch that with a very low number of consistency, which means it's very, very off.